Okay, everyone. In 1.9, we talked about resistance forces. Introduced two examples of friction and normal force, and let's call normal force surface resistance because it is the resistance of the surface, and in some countries it's called surface resistance, which I believe it's a very good name for it. So in these examples, M of the box for all of them is 5 kilograms, G is considered 10, 9.8 is almost 10, and we are looking for normal force. In the first case, of course, I can see that the force mg, which is trying to drag this down, which is the weight of this box, of course is 5 times 10, which is 50 newtons. So these 50 newtons wants to drag the box down and break the surface. How much resistance surface needs to show? Of course, exactly equal to this. So the N also would be 50 newtons. Now let's look at this other case. In here I have an F with an angle. I cannot deal with it. I have to divide it to its components as we have learned in our previous videos. First I determine my x and y axis. I draw perpendicular to x-axis. This is fx, which is actually pulling it this way, pulling it horizontally, and the other component is fy. Right now the fy and fx are the components of the f that we can deal with, so we don't really need f anymore. F is actually doesn't even exist because we are using these two, which will do exactly the work that f would do for us, and we are using these instead of f. The fx is dragging it horizontally, and we don't care about, because we are caring about vertical forces. So the fy, because we are looking for n, and n is vertical, so fy is the one that we take into consideration. Fy is the component that we concern about, and we can find it. We know that fy equals f sine 30. We have learned this formula in the previous videos, that and it's very easy for us. Actually, fy equals 40, which is f times sine of 30 is half. We know that, right? So the fy is easily found, is 20 newtons. So the fy is 20 newtons. The mg we know is 50. We calculated before. The mg is 50 newtons. How much n needs to appear here? How much resistance surface should show? In order to cancel this 50, only 30 newtons is enough, because 20 is already applied, pulling it up. So I know that the n would be 50 minus 20, which is 30 newtons. And I draw it from the center of gravity. It is 30 newtons. So the n is 30 newtons. The addition of these two vectors should be equal to this length. Now let's look at this other example. The person who is putting her foot on the box and is pushing it down is applying a force of 20 newtons to the box, pushing it down. So this is 20 newtons applied by the boot to the box, and the weight of the box is also applied from the earth, dragging it down by 50 newtons. So 50 and 20 are pushing down the box. How much resistance should the surface show? Of course, the n in this case would be 50 plus 20 because, and it's 70 newtons, because 70 is pushing it down, 70 must appear to pull it up and not let it to go down. So the n in here would be 70 newtons. Let's write a nicer 70 newtons. Okay. As you could see in here, it's equal, n is equal to mg. In here n is less than mg, and in here n is more than mg. So in most of the cases, in most of the problems, when you have a object on the ground, of course the weight of the object is, especially if the surface is horizontal, usually the n equals mg, unless there are special cases like these. However, in some cases we have a slope and an object is here and the surface is not even horizontal. In that case, we have a different situation which we will talk about in its own time. Okay.